Hello everyone, and welcome to another math tutorial. In this video, we're going to continue our discussion on solving quadratic equations using factoring. Alright, our first example problem, we're asked to solve the equation x squared minus 3x minus 28 equals 0 and to solve it by factoring. So if you're watching this video, I am assuming you already have a grasp on factoring. Maybe from whatever class you're in, maybe you watched my video on factoring a couple videos earlier in this playlist where I talk about how to factor quadratics. Either way, I'm assuming you have a background and can factor, so we're going to jump right into solving this problem. So I'm going to begin by getting my factors set up. X times x is going to get the x squared. And remember, you want numbers to complete this that multiply to negative 28 and add to negative 3. So we're going to use negative 7 and positive 4. Now, in order to complete this problem, we are going to use something that is called zero product property. Hey, zero product property says that if you have two numbers, or quantities, if you will, whose product is equal to 0, then it has to be true that either the first number of the product is 0 or the second number of the product is 0. In other words, the only way two numbers can multiply and give you 0 is if one of those numbers is 0. So we're going to apply that property to this problem and every problem that we solve by factoring. Okay? So we have a product right here. So this is like our A times B equals 0. According to this property, that means that this factor has to be 0 or this factor has to be 0. So I'm going to pull those apart as separate equations equal to 0. And I'm going to solve each of these equations. So this one I add the 7, I get x equals 7. This one I subtract the 4, we get x equals negative 4. Now, after you do enough of these, you will probably end up skipping this step right here because you're going to start to make that connection that whatever the sign is within the factor, it is the opposite sign in the solution. It's the same over here. We've got a negative number in the factor and the answer is positive. So we're always adding or subtracting the opposite when we solve those equations. Okay, next problem is x squared minus 49 equals 0. This is a difference of squares, so we can factor as x plus 7, x minus 7. Set each of these equal to 0. So I'm going to skip that step I talked about in the last problem. I'm just going to be subtracting the 7, so I get x equals negative 7, or I get x equals positive 7. Now, you might be looking at this problem and asking yourself, can I solve it another way? And the answer is yes. We could use the square root technique from the previous video. It's perfectly valid to take this equation and instead of what we did here, move the 49 over and get x squared equals 49. Take the square root of both sides and get x equals plus or minus 7. And you can see it's the same answer, just a different way that we can solve that problem. And really it's up to you how you see the problem and what direction you want to go. Next problem here, we've got back to 3 terms. We're trinomial, so it's not a difference of squares. Don't really have that square root option like I showed you in the last problem. We're going to go ahead and do this factoring. We need numbers that multiply to negative 26 and add to negative 13. We're going to use negative 13 and positive 2. So we get solutions of x equals 13 and x equals negative 2. Okay, hopefully you look at this one and note the obvious difference between this problem and everything else so far is this problem does not equal 0. So that's our first step, is to make this equal 0. We can't not use that 0 product property if there is no equal to 0. So I'm going to begin by moving the 2x over to this side and moving the 15 over to that side. And since they're positive numbers over here, they're going to be negatives on that side. So we're going to have x squared minus 2x minus 15. And taking those two numbers over to this side leaves nothing in its place. So now I've got my equal to 0. Once I'm set up equal to 0, now I can open up my factors. So x times x is the x squared. We want minus 5 and plus 3 to multiply and add correctly. So we get solutions of x equals 5 and x equals negative 3. Okay, final example problem where we're actually going to solve an equation. 3x squared plus 11x plus 6 equals 0. I'm going to start my factors with 3x times x, as I'm trying to get 3x squared. And now we need to multiply to 6. And I think to multiply to 6, I'm going to use 3 times 2. And I'm going to have to put the 2 into this spot and the 3 into that spot. That's going to give me a quick check here to get 11. I've got 3 times 3 makes 9. And 2 times 1 makes 2. And 9 plus 2 makes 11. So that's going to work. Now I need to set these equal to 0. Now this one, let's go ahead and show all the steps here because it's a little bit different with the 3 in front there. I'm going to have 3x plus 2 equals 0. So I begin by subtracting the 2. We get 3x equals negative 2. But then we have to divide both sides by 3. We get x equals negative 2/3. So we get a fractional solution there. That's okay. That's to be expected with that coefficient on the x. This one is just simply the opposite of 3, which is negative 3. All right, we're going to change it up a little bit in these directions. We're asked to write a quadratic function in standard form that has the given zeros. So essentially we're kind of like working backwards. Instead of finding the value of x that solves the equation, we have the values of x that solve the related equation that relates back to the function. So I'm just going to reverse the process, okay? So let's start, since we want a function, I'm not going to set this equal to 0, but I am going to start with just f of x equals. And what I'm going to do is I'm going to put it in a factored form first. Okay, so use factored form. All right, so if x equals negative 3, you have to think to yourself, what is the factor that would have given me the solution of x equals negative 3? And so think about that opposite nature of the sign here versus the sign there. I would want x plus 3. And if we have a solution of positive 4, that would come from x minus 4. All right, that's factored form. I want this in standard form. So what I'm going to do next is I'm going to multiply, or FOIL, if you like the acronym FOIL. We're going to multiply these binomials together. So I'm going to do the x times x, x times negative 4, 3 times x, 3 times negative 4. Okay, so there's my FOIL steps. I'm going to finish this by just combining my like terms right there. Get x squared minus x minus 12. There's the function that would have these as its zeros. All right, same directions on this problem. I'm going to begin by writing this in a factored form. So x equals 6 would come from x minus 6. And now this one's a little unique. It's a little tricky. We've got this 1/3 as our 0. This is what you probably do not want to do. Probably don't want to do that, because then when I FOIL, I've got to mess with this 1/3 fraction. There's a better way to do that. So let's start over again. All right, think about solving this as an equation, right? If I had an equation here inside this parentheses equal to 0, how do I get 1/3? Well, to get this 3 in the denominator has to finish with a division by 3. So I'm going to have a 3 in front of the x. And then to get this positive 1, I would have had to have a negative 1. So follow that two-step equation, right? If you take 3x minus 1 equals 0, you're adding that over, and you're dividing by 3. That's how we get the 1/3. So think of those fractional zeros as two-step equations. Put them in like this, not like that. They're going to multiply a lot easier without having to deal with the fraction. So now we're going to go ahead and do our FOIL product. Okay, and we're going to put our like terms together to finish this. And that's it. All right, last example problem. I'm giving you one that's about as hard as I can make it. You've got two fractional zeros. We're going to go back into a quadratic function in standard form. So let's go into the factored form first. And think of these again as two-step equations. That 5 in the denominator had to have been 5x. And then the opposite of negative 3 is plus 3. And this one's going to be 3x. That 2 is a positive number, so minus 2. Now we're ready to do our FOIL product. And then put your like terms together. And that finishes the problem. That will also finish this video. If you have any comments or questions, please drop them in the comment section below. If you want to support the channel, please give it a thumbs up. I want to thank you for watching all the way to the end of this video, and as always, I'll see you in the next one.